Hey guys, we're working on 2.2. We're talking about finding slope and rate of change. It's actually kind of an interesting point of reference here as we talk about this idea of a rate of change and slope. So when we talk about slope in mathematics, often we talk about the slope-intercept form, which is y equals mx plus b, and right there is where we find the slope. Now, one of the questions that I had as a young mathematician, as a student, was why in the heck do we use m for slope? I get a little bit why we don't want the s. It looks a little like a 5. It could be confusing. But m seems like a random letter to use for the idea of slope. But it's not random when you think about the fact that slope literally means the average rate of change. Okay? And when we talk about averages in mathematics, the most common average we often talk about is the mean. And that's where the m comes from. It's the mean or the average rate of change. So that's sort of a little bit of background into where this is coming from. By definition, when we talk about the average rate of change, we're talking about how much change there is per unit time or change there is per unit something. And so the way this is calculated, the slope is always calculated as y2 minus y1 divided by x2 minus x1 given 2 points, x1, y1, and x2, y2. So you have to have 2 points, 2 ordered pairs, but given any 2 ordered pairs, the slope between them can be calculated this way. The order of which ordered pair is x1, y1 and which one is x2, y2 doesn't matter as long as once I start my equation and I define what y2 is, I have to be consistent with the x. In other words, this y1 has to be associated with this y2 has to be associated with that x2 and this y1 with that x1. Also notice, we have these minuses built in here. That minus has nothing to do with the signs of the x's and y's. If the x is negative, if x1 is a negative 2, we're going to have minus a negative 2, which is going to indicate this double negation, or we're going to have the come out as a positive. So it's really important that we understand that. You'll hear concepts like rise and run is the other way that we'll talk about it. Rise being vertical, run being horizontal. And so as we go through and we look at this idea, that's essentially the big idea that we want to look at. Now, if we just take a real quick example, let's say that we had the points 2, 3, and 5. Let's go 5, 9. Okay, we'll go that route. Let's just call this x1, y1, and this x2, y2. If we go ahead and try to find the slope here, we take our y2, which is 9. We would minus our y1, which is 3, and we divide that by x2, 5, minus x1, 2. It's really important that if you're going to use the calculator to do this, okay, so it's important when we're putting this into the calculator, don't try to type it in all at once. If you do, you've got to use parentheses around the 9 minus 3, parentheses around the 5 minus 2. I'm a big believer in just type 9 minus 3 in the calculator, especially if there's some double negation. If you're concerned about your ability to get that accurate every time, double check yourself. But 9 minus 3 is 6, 5 minus 2 is 3, and then I'm going to check to see if this reduces. Oftentimes it won't, but in this case 6 and 3 both divide by 3, reducing this to 2 over 1. Often you'll see that written as just 2. For the purposes of talking about slope, I actually like the 2 over 1 better, because in terms of graphing, I can go up 2 over 1 and have that work. The 2 works really well in an equation. If I'm writing y equals so many x plus something, having a regular 2 there makes a lot of sense. Okay, so there's our idea of how we find slope. Now we need to talk about some different slopes we can have. If the slope is positive, it means that the trend is upward as you go to the right. A negative slope means it's downward as you go to the right. So you've got negatives, you've got positives, but you also have the potential of having 0 as your slope. A 0 slope means it doesn't go up as it goes from side to side. It stays flat. This is our zero slope, so m would equal 0. Equations like this, if you think about y equals mx plus b, would be like 0x plus, say, 3. Well, 0x would actually cancel itself out, and you'd have an equation that looks like y equals 3. So when you have a y equals a constant number, you're looking at a zero slope horizontal line. In contrast, if you ever end up with an m equals, say, 3 over 0, well, this means it's not going side to side at all. It can go up and down, it rises, but it doesn't run. Because it has no run, mathematically, this is considered undefined. We can have a bigger conversation in math class about why it's undefined and what that means, but suffice it to say that an undefined slope means we're going to have it be very vertical. Now, how does that come out in an equation? Well, it turns out that the y is missing in the equation. So this would be like x equals negative 2. Notice it's very similar to this equation, except that it's the x term that's defined, not the y term. Okay, just trying to clean a couple things up. How do we know if lines are parallel or perpendicular? Parallel lines are lines that never touch or won't get any nearer to one another. They must have the same slope. So if I say I have y equals 2x plus 3 and y equals 2x minus 8, because the slopes for both of these are 2, these two are parallel. Now, a line can be parallel. It can also be perpendicular. Now, a perpendicular line means that it's going to meet at a 90-degree intersection. Oh, excuse me. Oh, man. It's not COVID. Okay, just allergies. So one of the things that we're looking at here, we have to acknowledge that one of them is going to be negative and the other is going to be positive. That in order for them to go different directions, perpendicular is going to have opposite signs. So for instance, if I have y equals negative 2x plus 3, no matter what, the perpendicular would have to have y equals something positive with x. And again, I don't really care what this number out here is. It doesn't matter at all. Let's make it minus 13. There we go. But the slope has to be very particular. Lots of lines will intersect, but only very specific lines will cross at a 90-degree angle. We have what's called the negative reciprocal. Okay, that means it's opposite sign and it's flipped upside down. So over here we might recognize that this 2 is over 1. We're going to flip that upside down and we're going to change it from a negative to a positive. So now I would have 1 over 2. These two lines would be considered perpendicular. So I think that's pretty much all we have. The only thing left is to recognize how do we give units to these calculations. So let me just do a really simple one. Okay, if this is the number of hours you work, okay, that would be like your x, okay, and your y value is dollars, okay, that you make, and we graph a line. We would say the slope is our rate, equals the rate. So the question is, let's say that the answer is 10. What do we say it's 10? 10 what? If I say, I work so many hours, I got so much money, and I would say that I get paid 10, the answer would be $10 per hour. $10 per hour. So let's look at where these units come from. Whenever we're doing a slope, this number comes from the same place. It comes from the y-axis. And it's divided by the x-axis. So this is literally when we do rates of change, and we want to label those rates of change, dollars per hour or miles per gallon, it's always the y value divided by the x value, which should make sense because when we define slope, we talk about the y divided by the x. So when we're down here and we're saying dollars per hour, we're saying the change in y divided by the change in x. Okay, that is our identification of how we find slopes. How do we know if they're parallel or perpendicular? How do we label values so that they have meaning besides just the numeric value? how do we find those slopes, and so on. Hopefully this will be enough to get you into the concept of how we work with slopes and how they're going to help us in the coming sections in this chapter. All right, good luck, and we'll see you in class.